So let's continue. What I want to show you is how it gets harder. The way this gets harder is it becomes completely abstract, meaning that you're going to have to do problems where you solve for something, like solving for P, and there's going to be no numbers at all. And your job really will then become, do I know my rules for adding, subtracting, multiplying, and dividing when it only deals with variables or letters? This says you're supposed to solve for P. And we cannot put these together. The reason you cannot put them together is because this has an X and that has a Y. They're not the same variable. They are not like terms. But what you can do is this. You can use the distributive property. So underneath xp plus yp equals z, I want you to write p parenthesis, and then I'm going to fill that in a second, equals z. The p is multiplying by an x. The p is multiplying by a y. And the x, if I think about that, they're both multiplying a p. I can actually pull that out and I can pull that out. It's called factoring. I could actually factor out a p. And that is the same thing as what's left over, x plus y. That's what's left. What that does, Charlie, you have a question?
Would that be 2p or
no? Think about it like this, Charlie. P times x is the same thing as x times p. P times y is the same thing as y times p. It's going to go to both when we distribute. And now, since I'm solving for p, I want p by itself. P is multiplying this whole group. Since it's multiplying the whole group, the easiest thing to do is to divide by the whole group, x plus y. I can divide this z divided by x plus y, the whole group. And x plus y divided by x plus y equals 1. P will equal z divided by x plus y. It's a weird answer, but that's what our answer is. When you get to number 7, that's how hard it gets. Bless you. And that's not even as hard as it gets. If I were to show you something from the back side, I want to show you number 16 as well. Negative 2z minus xy equals x plus 7. And we need to solve for x. I need to get the x's by themselves. So here's what I'm going to do. Since I want to get the x's by themselves, I'll scoot this over to the left a little bit. Since I want to get the x's by themselves, I want this x on the same side as this x over here. So I'm going to add xy, and I'm going to add xy, and it's not like terms, so I can't combine it. So I'm going to write negative 2z equals x plus xy, and there's a plus 7 right there still. Here's my line. I added xy, and it can't combine with anything because it's not like terms. I'll zoom in a little bit more. Some of you look like you're squinting. And I want the x's by themselves, and I need to get rid of the 7. I can do the opposite of a positive 7. I can subtract 7 from both sides. And now I have negative 2z minus 7 equals x plus xy. I still need to solve for x. I still need to get x by itself. So what do I need to do? I need to use that distributive property again. There's an x and there's an x plus y. I need to factor out an x and factor out an x from both of these things. And think about what's left behind on both of these things. This is going to look weird, but it's an x times 1 plus y. The reason why it's a 1 plus y is because when we factor out an x from this term, there's still a 1 there. This times this is x, plus this times this is xy, equals negative 2z minus 7. I'm almost done. Now I have only a single x left. This single x is multiplying by 1 plus y. The opposite of multiplying by this group is dividing by that group. So what am I going to divide by?
1 plus y.
Exactly. This whole left side gets divided by 1 plus y. And the 1 plus y over 1 plus y cancels out. And this is the weirdest answer you've had so far. My answer is negative 2z minus 7 all over 1 plus y. That's what x is equal to. That is as complicated as it gets. What you have to do is you have to go step by step putting things together and undoing things to get it by itself. So that's like number 16. I have an example like number 8 as well if you want to see it. Well, oh yeah, let's do number 8 as well. I got one more. I got room for one more. Let me flip this over. 8. N equals P minus K all over J. Solving for P. We're solving for the letter P. It's N equals P minus K over J. This P is trapped inside these parentheses. You don't see parentheses because there's a bar right here that says this is in a group. So the best thing to do is to get rid of this divided by J. I want to get rid of this divided by J to get the P by itself. The opposite of divided by J is whatever we do to one side, we do to the other. When we multiply by J, this just becomes Jn. That means multiply. Jn equals P minus K. But I want P by itself, and there's something next to the P I need to get rid of. So what am I going to do?
Add K above the side.
Can you put that together with the Jn? Are these like terms? Since they're not, how do you write it?
Jn plus K equals P.
A few of you understand. That's good. Okay? So, at this point, I've given you 3 examples of how hard it gets. You should hopefully be able to finish all of 1.4 at this point.